Hemant, are we good?
Yes, Kinjal, you can go.
Okay. Good evening, everybody, and a warm welcome to Team Geomatics from Faculty of Technology at CEPT University. We have some amazing students, very enthused students, I should say that, and equally enthusiastic professors, the back-end support, I should say, who are constantly with the students, guiding them for different projects. We're going live now with their explanation, with their studio, and understanding different projects that they have done under Geomatics, which for a lot of people like us would be just another topic or just Google Map. So let's figure out and find out what exactly they've done. Over to you, Deepak, to start.
Yeah, thanks, Kinjal, for a very nice introduction. So let me introduce myself. So I am Dr. Deepak Samal, Program Coordinator of MTech Geomatics Program at CEP. And it's my pleasure to welcome you all to this virtual online exhibition. And in the next 30 or 40 minutes, we'll be talking about some of the works that our MTech Geomatics students have done in this pandemic situation. And this exhibition actually is a kind of academic celebration at CEP. And at the end of this semester, that was students showcase their work to their friends, to their visitors and industry people and other interested group with a great enthusiasm. So, so in the next 30 or 40 minutes, me and with me, Professor Anjana Vas is going to show you what are the work students have done. So we'll start with the first semester students, and may I request Professor Anjana Vas to please go ahead with the briefing about the first semester students, followed by student presentation. Over to you, ma'am.
Thank you, Deepak. Welcome to you all. The first semester studio this year is based on the resilient city. But before that, I would like to let you know that the first semester studio, where the students are fresh, they are from the multidisciplinary environment. They are from all parts of India, and hence they need to be bring to us synergies of learning of a technology, because this technology called geospatial technology is unique in its own nature. And hence we have to bring the student under one level of understanding. We have been designed this studio in the name of geo visualization, how they visualize the space, how they visualize the environment related to the space, how they identify the challenges which can be visualized over the geographical locations, perceptions, etc. And hence they would also try to learn the geospatial technology and try to use those into the concepts which has been derived accordingly. Every year we take the different typology of the theme. This year the theme is a resilient city. Looking to the pandemic situation, the studio was to design in disaster, and we said no, so much of disaster has happened now, how we can cope up, and coping mechanism can be identified using certain level of data, certain level of analysis, and a kind of base. And the base what we have taken is a resilient framework, and the students have gone through the journey of learning, understanding of the data management, GIS, geographical information system software utilization, and the theme of resilience framework have been analyzed and placed before the during the semester journey, and they have come out with some kind of solutions or a kind of analysis, and we would like to see those analysis now on. And that's why I will ask Shweta to run a video what our students have prepared. The studio is designed for the whole semester with the 3 groups of the students, and the video itself is a self-content which will let us know what are the themes and how the students have walked through but learn as well. Thank you. Thank you, Shweta. Can you just take a call?
Yes, ma'am.
Yeah.
Greetings from the Geomatics program from Faculty of Technology of CEPT University. We welcome you all to embark upon our journey of Foundation Studio for Geographic Information Science. The theme of our studio is Resilient City. Cities are considered as living laboratories for innovation and opportunities. With ever-increasing population and demand for infrastructure, proper planning and management is needed to handle these complexities. Cities do experience disaster of various nature with different intensity. Hence, we the student have tried to address this issue using GIS and a case study-based methodology. Before beginning, we would like to present our deepest gratitude and sincere thanks to Dr. Anjana Vyas for being our chief mentor and supporting us throughout this journey. Her knowledge and experience has been very helpful to us. She has always remained with us, encouraged, motivated, and raised a deep interest towards the studio-based learning. We are also grateful to Dr. Uma Maheshwaran for discussing and developing fundamental understanding on resilient framework. Our heartfelt thank you to Dr. Shaili Gandhi for laying foundation of GIS theories and practicals. We, the 17 students, all from different backgrounds of civil engineering, planning, architect, geography, and geology, have joined hands together in completion of this. Due to the pandemic situation of COVID 19, this was the first ever online batch of Geomatics program. All our class from all across the India, namely Uttarakhand, Uttar Pradesh, Gujarat, Maharashtra, Madhya Pradesh, Andhra Pradesh, and Kerala have joined hands and worked on this studio from the comforts of our home. The aim of our studio was geovisualizing resilient cities. The objectives that were gained are to learn fundamentals of geographical information system, to develop the basic understanding on urban governance and urban challenges, to examine the resilience framework with respect to urban challenges, and to develop resilience strategies of smart city. Being from the first semester, the entire concept of studio learning started from a scratch. We were given deep knowledge and understanding of GIS-based theories and practicals. In this process, we learned about georeferencing, how to effectively manage our data using joints and relate. We learned about digitization, and we also learned to create our own maps based on our thematic needs. The next focus was given on concept building. In this, we learned about the demography of the study area of Ahmedabad and gained knowledge about its growth pattern using the Census of India data. Then we focused on the administration of Ahmedabad Municipal Corporation and tried to understand the governance and working of the city. At the end, we tried to accumulate all the necessary data for our analysis from various portals like Bhuvan and Vedas. The next step was focusing all on urban resilience. We learned that what is city resilience, what are the important 7 characteristics of resilience, and also we learned about interesting resilience concept like hazard and vulnerability, resilient framework, shocks and stresses that a city faces, and we also did a case study on the existing resilient cities of Surat and Pune. We brainstormed and tried to identify all the city level issues like solid waste management, traffic congestion, urban floods, sanitation, public health services, lack of open ground, lack of green spaces, etc. We then tried to connect our selected challenges with the resilience framework, which is divided into 4 main pillars of health and well-being, economy and society, infrastructure and environment, leadership and strategy. These 4 main pillars are further divided into 12 indicators followed by a sub-indicator. Our classroom exercises include various practical sessions and assignments that help to build our concept even better. We performed a lot of tasks and exercises on Miro board and created various flowcharts and mind maps that helped us connecting our analysis and findings to the resilient framework in a more systematic way. During this process, we were privileged that we had an opportunity to attend and interact with the people who were expertise in their respective field. The expert lecture gave us a lot of insights about the current working of Ahmedabad city and also helped us with data acquiring. Name a few. We had expert sessions from Mr. Vishal Khanama, Dr. Rutul Joshi, Neha Upadhyay, Dr. Shubhranshu Goswami, Dr. Mona Kakkar, and many more. Finally, three challenges were taken by the class, and that were urban mobility, where we tried to propose new My Bike stop on the eastern side of the Sabarmati River, urban flood, where we found out the existing facilities that can be used to relocate slum in case of heavy floods. And the third was solid waste management, where we tried to check out vulnerable areas and proposed sites for air purifier at certain location and also did a check for landfill site suitability. So that was how our entire studio went. Thank you.
Thank you, Shraddha. That was definitely a very interesting presentation that the students have prepared. Professor Anjana, would you take over?
Yeah, this will be followed by a small brief presentation by the three groups. Will you please now start presenting?
Yes, ma'am.
Yeah.
Yes, ma'am.
We share your screen?
Shraddha, can you share your screen, please?
Yes, ma'am.
Yeah.
Monish, you can
Yeah,
start.
Shraddha, can you go to the next slide, please? The urban mobility one.
Yes.
Yeah, so good evening, everyone. My name is Monish Patel, and I'm from Semester 1. So now you know about the theme of our studio, which has been resilient cities, and we have been selecting some of the urban challenges for the same. So our first challenge is the urban mobility. So we started by comparing it with the resilience framework. So we would be looking at how urban mobility is affecting the different indicators of the resilient frameworks, the seven characteristics of the resilient framework, how they affect the urban mobility, and we have also been analyzing the different stresses which act on the urban mobility. So for the we have divided the analysis in seven different parts. So first and the second part is studying the present connectivity of the entire Ahmedabad city. So the first part is about studying the connectivity of the major roads, arterial roads, also the railways and the airports. The second part is about studying the connectivity of the public transport, which brings into the AMTS and the BRTS services in the entire Ahmedabad city. The third part is studying the traffic congestion, so which are the major spots or the roads where the traffic congestion takes place. And then according to this traffic congestion spots, we have been identifying what is the road width at this traffic congestions, and also the population living in the nearby regions of this traffic congestion. So the next part, which is the fourth part, brings us to flash flood. So we have been analyzing what are the flood prone areas and also what are the waterlogging areas in the entire Ahmedabad city. And we have been analyzing, we have been doing a buffer analysis that what are the areas affected due to this waterlogging in the entire city. Next part brings us to the noise pollution analysis. So how what are the critical locations in the city where the noise pollution is really high, which exceeds the permissible limit. And for study analysis, we have been taking the Navrangpura area, which is a pretty much university area. So how noise pollution affects the population and the health of the individuals in general. So if we look at the graph, we can see that how noise pollution is actually pretty much higher than the permissible limits. Then it brings us to our fifth component, which is the air pollution analysis. For this, we have been using the process of interpolation,
and we have been finding which are the major areas where the air pollution is relatively high, with the air pollution stations installed in the entire city. And after studying of all these stresses on the city, in order to enhance the mobility of the entire city and to make it more resilient, we have been proposing the solution of my bikes. So we are, the last part is about the my bike analysis. So my bike are the cycling service which are on in the entire city. So we have been first looking at the present connectivity of the MyBike service in the city, and what are the vulnerable areas where we can implement the last mile connectivity and enhance the MyBike services and in cycling in general. So we found the east portion is highly vulnerable. So we have been analyzing the east portion, and we have been proposing some of the locations where we can place the MyBike stops. So in order to enhance the overall mobility of the east portion and the entire city. Yeah, that's it from the urban mobility. Next part will be taken by Karan. Thank you so much.
Shweta, next slide, please.
Karan, it is there. You can start speaking.
Okay, we have taken the urban flood as one of the hazard for the resilient city. So we have taken the city for the analysis of the urban flood, that how the flood is affected to it. So we have taken first the vulnerability of slums. For that, we have taken the west zone of the Ahmedabad city. So we use the buffer for the slum areas, our complaint points, and from that we connected our complaints points buffer to the slums areas. So we find out from that how the buffers how many slums areas are there in the buffer. So from that we come to know that most of the buffers are having most amounts of the most of the complaint data is having most of numbers of slums. So we connected vulnerability of slums with the urban flood, taking the complaint data as one of the things. The other was the vulnerability of stormwater drainage network. In that we have used the we use the stormwater drainage network of west zone, and from that we come to know about the west zone drainage system. And in that we use the line density, so we come to know about the densities of the water drainage network in the certain areas of the west zone. From that we use the non-functional pipelines data. In that we put the complaint data near the pipelines and found that the number of data complaints near the pipelines, and from that we find out that the non-functional pipelines coming from the data complaint data, as if so the complaint data are more near the pipelines, that means the pipe is not functional or something problem is created there. So we can uh, go through that and change the pipe, or some problems can be deducted through it. Then we use the vulnerability of buildings. In that we use the building footprints and the complaint data also. In that we use 200, 200 and 250-meter buffers. And from that we counted the number of building footprints in it. From that we also counted the number of population affected. We taken the total number of population upon divided by total number of footprints. So we get a number of people per each footprints, and then we multiplied it with the average number. So we found out the number of people affected in that. For the resilience linkage, we use the root analysis for the resilience. So in that we have taken the complaint point or of water flood area point, and from that we use the hospital and schools as one of the root analysis. And from that we made an route that is very much preferable, or that is very much easy to reach over the point from the flood prone areas. So there are three maps. From that we use the first is about the hospital map. From that in that hospital map we use the network for the slums to the hospital area, and which easy or suitable network is there. And the second map was from the school slums to the school areas or the nearby residence place where that people can be safely reach there. And from that also we made a route analysis for that. Uh, And the other thing that we taken in the consideration of our resilience was to how the people can be rescued, or which other facilities are there to improve the resilience of the city in the west zones. So if any flood or anything can be occurred over at a certain time period, how can we change, or the people can be settled from one place to the other place. Thank you. And the next slide will be taken by Aditya Singh.
Aditya?
Very good evening to all of you. This is Aditya Singh, who is going to talk about the challenge which is hidden but can be affect the most, solid waste management. The impact of poor waste management is so vast that it cannot be addressed by one solution. Hence, our work is also diversified. We have taken two types of analysis, ward level analysis and city level analysis. On a smaller scale, if we visualize the location of open dumps, we conclude slum and water bodies are most vulnerable in the terms of solid waste management. To be more specific, nearly 45% of open dumps were in the proximity of 500 meter of water bodies in South and New West Zone, whereas 118 open dumps location were in the proximity of 100 meter of slum location in the Central Zone, creating the stress of solid waste management in whole system. We used various geovisualization techniques and proximity tools to correlate the open dump location within the land use and other contributors to find the most vulnerable ward in the terms of slum solid waste management, as well as open dump near the water bodies. However, at city level, we have bigger stress, that is the landfill site of Ahmedabad, Pirana, which has been used since 1982, spread over 82 acres, height of 75 feet, and 70 lakh metric ton of waste, which comes within the city region. The air pollution data of city shows significant high values of PM2.5 and 10 around Pirana, making it more vulnerable for the residents around there. We have proposed air purifier location also for immediate improvement of air quality as well as for to get rid of foul smell. But to keep future in our mind, using weighted overlay techniques, we have identified the most new optimum location of landfill site considering the CPHEEO criteria. Hence, by this, we Geomatics first year students tried to address all the pillars of city resilience framework, from health and well-being by waste management to economic and society by flood management to infrastructure by mobility, and nothing is possible by land by nothing is possible if leadership failed. So I invite all of you to go our SEPT exhibition website and see our detailed analysis and work. Thank you.
So, thank you. Uh, thank you all. No more presentation from first semester studio. They have just made presentation about what they have worked and how they have come out with the conclusion of the three typical problems of urban local bodies and the people are facing. Thank you. If it is possible, we can take the questions. Students are ready to answer those questions, how they have gone through, either on the methodology or analysis or data management or any outcome. Thank you.
Thank you, students. Thank you, Professor Anjana. Before questions, we would want Deepak to, introduce the other studio and also look at the other projects, and then perhaps we could figure out on the questions.
Oh, yes.
Great.
Sure,
Great.
sure. Yeah. Okay. Yeah. So thanks. So I'll be starting with third semester studio, that what exactly I've done. So in the third semester studio, this time the theme was geospatial modeling and application. So where me and Professor Darshana Rawal along with Ashish Upadhyay were the part of the studio. So in this studio, we have explored that several spatial models, their working principle and application in various thematic areas. So in that specific studio, actually, we asked students some of the pertinent question like what exactly is a spatial model and what processes you are going to model and what problems that you are going to solve using those models and what are the input parameters in that model and how and when you should calibrate a model and how to identify the spatial and non-spatial parameters in that specific model that you're going to use and how do you validate a model and what are the ways actually you can evaluate the model performance and how do you interpret and apply those modeling outputs. So these are some of the questions actually asked our students, and the students actually tried to get those answers to their respective thematic areas. And as a class, we have divided into maybe more broadly 6 categories where students have used those models and tried to come out with some kind of solution as well as the application in their respective thematic areas. And these groups are LULC change modeling, our urban green space, and urban sprawl modeling, air quality assessment, and urban heat island studies, as well as water resource and flood modeling studies. So now may I request students to present their work one by one. We can start with the LULC change modeling group. So Krina, are you there? Can you please go ahead and present the work?
Yes, sir.
Yeah.
So I'm starting with the first theme, that is LULC change modeling and its application. So LULC refers to the classification and categorization of the human activities and the natural elements of the landscape. Land cover documents how much of a region is covered by the forest, wetland, impervious surface agriculture, and the other land and the water types, whereas the land use shows the how people use the landscape, whether for the development, conservation, or the mixed uses. LULC maps plays the significant and the prime role in planning, management, and monitoring programs at the local, regional, and the national levels. So it helps us to study the change that are happening in our ecosystem and the environment. Therefore, LULC changes are an important aspect of the land management, and I used to predict the LULC changes for the sustainable land development. The study area for our study we have chosen is the Ahmedabad city, which is situated along the banks of the river Sabarmati. A buffer of 2.5 kilometer was taken around the AMC boundary, and that the whole area of about 934.32 square kilometer is taken as the study area to understand the future expansion of the city. The city of Ahmedabad is governed by the Ahmedabad Municipal Corporation, and the area of approximately 466.35 square kilometer is covered, and the greater Ahmedabad is under the jurisdiction of the Ahmedabad Urban Development Authority. The various factors which affect the LULC change were considered as the transportation, the land prices, population density, road development, employment opportunity, and the location of various amenities such as the parks and gardens, etc. The entire studio was divided into the 6 phases. In the first phase, we understand the geospatial modeling and its application, the types of geospatial modeling. Then case studies were done for the LULC change modeling, and the different models were understand, such as CA, Markov, MLP, and the sleuth model. The second phase includes the data collection, like list 4 satellite images for 2007, 2011, 2015, 2017, 2020 images were used, and the other auxiliary data such as the AMC city boundary or the road and the rail shape files, the population density data were taken, and this data were further processed. The third phase includes the LULC classifications of the images. Here first we have compared the two methods of the classification, that is first is maximum likelihood classification method and support vector machine. The accuracy was checked by the kappa coefficient, and later the method which gives the best accuracy was used to classify the further images. LULC classification was done for at the two level. The first level included the classes such as built up, water body, dry river, road, agriculture land, and the open land. Further, these classes were further divided for the level 2 classification such as built up, dense, and the sparse. Water body was bifurcated into river, canal, lakes and ponds, cropland, fallow land, plantation, road, open land, and the dry river. The fourth phase includes the analysis and the change detection by making the persistent map transition maps. The fifth phase, we have chosen the four models, that is ANNCA and CA in the R environment, MLP-MC, and the LACA, and they were compared, and the best suitable model for use for the future prediction. And the last phase is the application phase. The aim of the studio is to produce a land use land cover map of the Ahmedabad city in order to detect the changes that have taken place over a given period and predict the future LULC using the change detection models. To prepare the LULC map of the Ahmedabad city at a scale of the objective of the study were to prepare the LULC map of the Ahmedabad city at the scale of 1 is to 10,000 using the list for satellite data for the year 2007, 11, 15, 17, and 20. Then analyze the spatial and the temporal patterns of the land use land cover change for the change detection. To evaluate the various models for forecasting and determining the best suitable model for predicting the LULC. Estimation of the amenities for the population growth in the predicted LULC. After that, the analysis of the level 1 and the level 2 classification was done, from which we can say that there is a great increase in the built up area. The open lands are converted into the other land use classes. For this detailed analysis, change detection analysis is done, which is a method of understanding how a given area is changed between the two or more time periods. Firstly, the transitions from the open land and to the built-up dense and sparse was analyzed, and persistent maps was created to show the changes which have remained unchanged from the year 7 to 2020. Then the concentration of the built-up dense and the built-up sparses was analyzed. The gains and losses in the fallow land were analyzed. Then from the transition matrix, the charts were prepared to understand the transitions of the land use from one class to the another class. The different driving factors which were taken into considerations were for the LULC change modeling were slope, distance from road, BEM, distance from railway. The general modeling approach includes the inputs of the LULC layers and the other driving factor. Then the models are selected, the training parameters are given, and then the model is trained to check the accuracy. After calibrating the model, it is rerun till the desired accuracy is achieved, and then creating the potential map and then future prediction, and finally the validation is done. The first model we selected was the multi-layer perceptive neural network Markov chain model, for which the Clark Lake Idrisi software was the used. It is a fully connected neural network. The second model we used was the logistic regression CA model, for which the open source QGIS version 2.16.3 was the use. The overall method was divided into the 6 steps. The third model used is the artificial neural network cellular automata model. Though it is divided in mainly two modules. The first is the ANN based probability of occurrence estimation model, and the second is the self-adaptive inertia competitive mechanism CA module. And the fourth one is the CA in the R software environment, which is termed as the SimLander, which stands for the simulation of the land change using the R. The advantage of R is the huge range of spatial statistical analytical packages and the flexible command line maths operation. The only limitation for this is only deals with the one land use at a time. Then all the results of the obtained from the model were compared with the original LULC images. Here the 2015 LULC is predicted using the 2007 and 2011 LULC images and compared with the original 2015 LULC classification. By analyzing the best two suitable models were chosen for predicting the future LULC of the 2033 using the LULC of 2007 and 2020. The magnitude of the changes in LULC was recorded high in the specific area situated at the outer part of the Ahmedabad city. The process of change has been shifted from core to the periphery region, and the western side of the Sabarmati River has developed in the recent past and has experienced a significant transformation in LULC as compared to the eastern side of the Ahmedabad. For the application purpose, so we have selected the region having the maximum land use change, and then residential plots were extracted from the development plan 2021. Then FSI is identified based on the selection of the study area. The date based on the data of development plan, number of floors were calculated from the total built up area and the maximum plot coverage. As per the NFHS, average household size is 4.8, and based on this household size, number of floor population were calculated, and based on this estimated population requires amenities were calculated using the URDPF guideline. So as per the result, we have selected the Gota ward for this study. As per the URDPF guideline, various amenities were analyzed and the population served and the number of amenities were estimated. The conclusion of the studio is from the year 2007 to 2020, there are major changes in the land use like open land and the green cover, which has decreased from 11% and 4%, and the built up area has increased by 12% of the total area. Among all the model, MLP-MC model gave the best results for the future prediction. The magnitude of the changes in the built up was recorded high in the areas such as Gota, Thaltej, and the Science City. The distribution of the population will increase due to the increase of the built up area and is so in the demand of the public amenities. As per for the future work, we can say that site suitability can be done for the proposed facility by using the multi-criteria decision-making approach, and the level 3 detailed classification study can be done by using the fusion images of the Carto set with the list for together 2.5 meter panchromatic data sets. Thank you.
Thanks, Krina. Maybe next group may quickly come in. May I request Medini, part of
Yes,
our
sir.
open green space group, and we can quickly go through what exactly you have done. Maybe you can focus more on the results and
Yes, sir.
yeah. Please.
Can everyone see my screen?
Yeah,
Yes, Medini, I'm just interrupting here. We have
Yes,
another
ma'am.
15 minutes, so you'll have to quickly wrap so the last group could also share what they have to.
Yes, ma'am, of course.
All right, thank you.
My group consists of 4 people. There is I am Medini. There is Harish, Sindhuja, and Nikita. The 4 of us did this project in 3.5 months, and we concentrated on understanding the change of urban green spaces in mega cities of India like Hyderabad and Bangalore. Urban green spaces are very important for us to have a healthy, balanced life, as in we need to have a good balance of nature along with our increasing built form. So we divided the study into 4 major phases. The first one was to understand the spatio-temporal distribution of vegetation cover in both the cities from 1989 to 2019. The second was to understand the risk posed by increasing built area on green spaces. The third was to predict the land use scenario in the future. And the fourth was to try and understand why we are doing this study, like what is the point of studying urban green space change. So quickly jumping into our process, the first one where we had done the time series analysis to understand the spatio-temporal distribution. If you look at the results, you can see these are the maps for Bangalore, and you can see that vegetation has drastically decreased while urban area has increased. When it comes to Hyderabad, you can see that vegetation has more or less remained the same. Urban has increased in open land, which is majorly rock outcrop, has decreased. So this is the understanding of the past from 1989 to the present 2019. Coming to the present scenario of the study, what we have done is we have tried to analyze the risk posed by this increasing urban area on the vegetation. So here, if you look at the results of our risk analysis, which was taken as a function of resilience and exposure. So resilience is something we got from the NDVI, the normalized differential vegetation index, and exposure was directly taken from the classified images. So here, what we have tried to understand is how the proximity of urban spaces impact the vegetation. And you can see all the red areas are which are they're highly impacted. The green areas are untouched, and the yellow areas are somewhat stable where there is no immediate risk. So what we have done is we've taken the past, the LULC, and the present, the risk, into our future modeling to understand how green spaces are going to be in the future. So we did three case scenarios where we had one without any restrictions. The first one is without any restriction. The second one, we had taken only water bodies as our restriction. And the third one, where we have taken the LULC from the first phase and the risk from the second phase. And we have tried to understand how they differ. So when we did this, we understood that when there is no risk, a lot of the green spaces, if you can see these images, in the first scenario, a lot of these green spaces have disappeared in the first restriction in the future. In the second restrictions, when we have only taken water bodies and reserve forests, few of the major tracks have been protected. And when we have taken the risk layer into consideration, a lot of wetlands have also been protected. So we did that for um, various scenarios for both the cities to understand. So, and finally, we try to compare our results with the land surface temperature. So we see that when we do this study, the land surface temperature, though vegetation directly doesn't affect, it still has an impact on its immediate surroundings. So coming to the inference of our study, in the first phase, we have seen that vegetation cover in the last 3 decades has changed in both the cities in different ways. In Hyderabad, as I've already shown, it has remained more or less constant. It is the open land that has changed into built up. Whereas in Bangalore, because it's already a garden city, a vegetated city, vegetation is the one that changed into built up. So this shows that though urban expansion has an effect on the change of green spaces, it is a topographical and climatic factors that affect the initial extent of vegetation. In phase 2, where we did the risk analysis, we saw that green patches which are in the direction of urban growth have collapsed or are fatigued, whereas green patches which are a combination of different vegetation types and are under protection of either a government, an institute, or any other authority tend to be stable and rejuvenated. In phase 3, we have tried to understand how this changes in the future. So as I explained in the various restrictions, we understood that it is important to take these risk areas into consideration to protect them for the future. And in phase 4, we have tried to show correlation between temperature and green spaces. And we have understood that though there is no direct correlation, it is still important for us to understand because green spaces directly affect the microclimate of any place. So the conclusion is the past, the present, and the future, along with the impact of green spaces on the environment, show that it is vital to protect and preserve these green spaces for the health, society, and sustainability. And we have done all of this using various modeling processes, different types of data on a variety of proprietary and open source softwares. So thank you.
Deepak?
Yeah, thanks, Medini. And now we can jump into air quality monitoring.
Is this going to be the last one?
No, we have a couple of more.
No, so I'm sorry, but I'll have to cut short here for a simple reason that
So
we
they
have
will
another
come.
faculty waiting in line,
Okay.
Faculty of Management, who would begin their virtual tour as well.
Okay.
Do you want to
So
continue again on another date and time?
no, I think that would be not seems ideal.
Okay. So
Maybe I can the last project I can call maybe the flooding group. I can see
okay.
some good output. Maybe that we can take up before
Can
we
we?
wind up. Yeah.
Yes, we can wind up with that.
Yeah.
I would request the students who are presenting I can't spare more than 5 minutes. I'm sorry, but you'll have to wind up in 5 minutes.
Yes, ma'am, sure. I'll make it as short as possible.
Yeah.
Thank you so much. Thank you.
I hope all of you can see my screen. Uh, good evening,
Yeah.
everyone. I'll be focusing on the flood inundation modeling. So the aim of the studio was to study the 2019 flood situation for Vadodara city using a geospatial modeling approach. It contained objectives to analyze the rainfall pattern for Vadodara city, to simulate and inundate the flood model extent for Vadodara city using HECRAS, to prepare flood risk map for Vadodara city based on various social and economic parameters, and also to prepare a dashboard using WebGIS. So this is the methodology. We started with the literature review to selecting the study area, then data preparation, calibrating and executing the model based on the accuracy, validating the model result based on ground data, flood risk assessment using AHP for flood hazard and vulnerability map, and decision support system using WebGIS and a dashboard. So the study area was taken as Vadodara city for analysis, and a watershed was derived using GIS, which is the watershed of Vishwamitri River. So here we are analyzing the flood on Vishwamitri River. So to do our modeling, we have collected several data. We took rainfall data from GPM Google Earth Engine, and for land use data, we have taken list for image to classify into various classes. So for flood inundation modeling, we require the discharge data. So we are using HECRAS model, which is a completely open source model, which helps us model the flow of water on the surface of the earth using physical, mathematical, and geographical concepts and GIS concepts. So here we have modeled the discharge for Vadodara city. So it models the amount of discharge that will enter the Vadodara city at a particular time and a particular cross section. So this is the beauty of GIS in the way how we can to take the discharge of any point according to our study, and HECRAS supports this GIS capabilities with the HECRAS mapper. Then after finding out the discharge, we compared our discharge with the standard ground value which we had, and we calibrated it using land use land cover classification so that we can get better accuracy and match the ground results on a better note. After we had our discharge value, we made the inundation extent model. So we basically are modeling flood in the city of Vadodara. So this will help us to know if there is any flood-like situation, where will the water inundation be. So this will help us in better preparedness and response for flood-like scenarios which can happen in future of the same or different intensity level. So here, using all the calibrations and modeling processes, we had gotten this output. So HECRAS provides us output in terms of velocity, depth, and water surface elevation. So for analysis, we have taken depth as our output, and we have exported that to ArcGIS. And as you can see, for the date and time that we required. So actually, we have modeled the flood initially for 31st July 2019 in Vadodara, which was a big flood event of that year. So here we can see we had, using the modeling techniques, we had mapped the flood inundation extent using the HECRAS model, and the same was validated using using the ground data. So we had the data of where the inundation took place in the form of a text data, which was digitized using ArcGIS. So here you can see that the model outputs and the ground data are complementing each other, and thus proves the validation. But the basic need for validation, basic need for modeling is to predict or generate future scenarios for better preparedness. So that we will look ahead in nature. So before doing that, we analyzed our output and we observed that the built-up area was the most vulnerable area. So these are the modeling scenarios that we generated. So we increased our rainfall to 25%, 50%, and 100% respectively to see how the inundation will vary based on increase in the rainfall. So here you can visualize the outputs and see the inundation area is increasing to a large extent, and it's almost getting doubled when we look at the statistics. Now, to put all this into perspective and to make it good for use, we have made a flood vulnerability and hazard map where we have used decision-making approaches, where we have taken physical parameters in the flood hazard map and socioeconomic parameters in flood vulnerability map, which includes population density, households, Euclidean distance, pervious layer, slope, CN number mat, precipitation, to name a few. So from here we can see that the wards near the Vishwamitra river are more vulnerable to flood, and the wards which are away and with high population comparatively lesser vulnerable to flood. Also from the flood hazard map, you can see that if a flood, at what places are the flood-like situations more likely to happen. So you can see that the areas denoted in red are more hazardous to flood than the green. This is due to these maps are generated based on all the input parameters that we have taken and the weights that we have calculated using AHP. So now we have combined both the maps, and here you can see a specific point level map, pixel level map of what kind of risk is associated within each pixel, and then we have generalized it to ward level. So here from this map, anybody can infer that which ward is the highest risk ward when it comes to flood. So it can be noted that wards number 8 and 1 are the highest risk flood, with ward number 12 being the lowest. So this map summarizes all the physical, social, and economic parameters for a better understanding of the flood. So also to analyze the output, we have overlapped our model output on the risk map to show that how the risk will increase in the corresponding wards in the future. To summarize all the outputs, lastly and at the end, we have made web GIS based dashboards when we can upload all these layers, update them automatically, analyze public response, and do various kind of analysis, query based analysis, overlay analysis. So these kind of tools can be very helpful to Vadodara Municipal Corporation, who can analyze the data and who can also, with the capability of these web boards, they can also measure the distance, the area to be inundated, and can be prepared for further scenarios. So this was the flood inundation thing. Thank you.
Thank you, Aditya. Deepak, would you like to conclude the session?
Yes. So thanks, Aditya. So apart from that, we have also more number of thematic areas students have really worked hard, like our urban sprawl modeling by Disha and their group, and air quality. They have really done good thing. Plus urban islands. Okay. So overall, they have put a very nice effort in terms of the understanding the problem, and specifically in this pandemic situation, they have worked with a minimal support from our end, and they have really exploded a lot as a part of their studio studies. So I wish all the best and thanks for being with us in this event. Thank you all.
Thank you, students.
Over.
Thank you, professors. It was definitely a wonderful session, and we would want everybody to look at the projects on the exhibition side and have further in-depth knowledge on the students' work in the Geomatics section. Thank you so much, everybody. See you soon.
Thank you.
Thank you. Thank you so much for supporting us. Thank you.
Thank you, ma'am. Bye.